Hi Hires, we are still looking at metabolism and survival. We are now looking at how different factors can impact on metabolic rate, and in particular two new terms, conformers and regulators. Okay, so first off, you should just recognise and be able to deal with the concept that anything which impacts on functioning of cells, in particular enzyme function, would impact on metabolic rate. I mean, that's a pretty clear statement that I think should not be a problem. And you could easily lift examples where you go, okay, temperature, I know exactly how that impacts on enzymes. You've got your standard temperature curve, which you should be able to kind of sketch out at any point. Okay, you've got your pH curves, which you know are affecting enzyme functions as well. Salinity may be a little bit trickier, but what you're then looking at is either the movement of ions, which will affect osmotic balance, it'll affect how easily things can move, so that can have a huge impact as well. Okay, so if we look at animals, we can split them into two distinct groups according to how they deal with the change in the external compared to what happens inside them. Okay, so conformers are the first big group, and what we mean by that is that their internal conditions conform to the external condition. So if it gets hotter outside, it gets hotter inside. They don't keep their internal independent of the external. It is dependent on the external. So there is a problem with that, because what that means is they can only live in conditions that support their level of metabolism required. So if, for example, you need 20 degrees C to give you all of your enzymes functioning at the level which gives you your metabolism running to keep you functioning, then anything below 20 degrees is not an option. They can only live at 20 degrees or higher, and then there'll be an upper end that they can't go past as well. So it tends to narrow the range that they can deal with. What they also do in terms of trying to deal with metabolic rate is they will use behavioural responses, and I'll deal with that a little bit further on as well. Second group are regulators. This is where we fit in. Okay, regulators will maintain their internal conditions regardless of the external conditions. So you're going to have to know one specific loop, which is going to be temperature, but this is your negative feedback stuff that you had at Nat 5. What they're going to do is use cellular metabolism to regulate the internal environment. So that is homeostasis, keeping things in a steady state. As I said, negative feedback. If you need to go back and look at that in Nat 5, go back and look at it. But what's really good about this, and it's an expensive thing to do, but at the same time, it will give you a much greater ecological range. So if we look at how heat moves, these are words that you would have done way back first year: conduction, convection, radiation. These are all forms of moving heat, and all of them are really important in the overall balance of what's going on internally. Evaporation is in there as well. That is a very powerful and important movement of heat, because we use that in our cooling systems in terms of sweat, because it takes heat away as it evaporates off the sweat. So this is a balance, as I say, to get your internal the where you want it to be. So ectotherms, these are our temperature conformers. They are what we would call cold-blooded, but we're not going to use that term. You're going to use ectotherm. And they use behavioural mechanisms, because these are conformers, to regulate their temperature. And the one that you're expected to know is basking. So what we mean by that is when they need to up their metabolic rate, they will move somewhere which is warm, and they will try to absorb some of that heat to get their metabolism running. And when it's too hot, they will go to shade. They will not actually, so we're not using internal structures to make this happen. They're using behavioural things to make it work. Pros about this, and this is a really important one: if you have a low metabolic cost, that means you don't have to eat as much. Con of that, narrow ecological range, because any extreme is going to move them out of their tolerance, so they don't have a high resilience to change. This was an article from 2018 which I thought was quite interesting. What happened in Florida? Florida doesn't generally get very low in terms of temperature, and they had an extremely cold spell for Florida. Temperatures went under 7 degrees, and what happened with these giant iguanas that normally just stood up in branches in the trees or clung onto them, their metabolism dropped so far that they just fell out the trees, and there were these big giant iguanas lying on the pavements, and they thought they were dead, but actually they weren't. Basically, and so what they were told was, if you just move them carefully into the sun and allow them to just absorb a little bit more temperature, a little bit more heat, then they will come round. They're just at a very low metabolic rate. So endotherms, on the other side, so this is us, are temperature regulators. Endo meaning inside, so internal temperature. Okay, but we're going to have to use physiological processes to keep that regardless of the external, which is your physiological homeostasis. And the biggest thing, as we've already said about this, is that it broadens the range. It means that you have a larger area that you can deal with, and if things change, you're more likely to have processes that will allow you to survive. I've alluded to this throughout it, but really what we're talking about here is cost. It is expensive to choose to regulate. So you have to decide how much regulation you're going to do. Is it behavioural? Is it physiological? And what is the balanced cost of that compared to how much you can then forage and how much you can actually live in different places? Okay, that's that one.